All right, so exercise 5. A car manufacturer is interested in conducting a study to estimate. So again, that word estimate tells us that we're doing our confidence interval as opposed to testing something, which would be a hypothesis test. And what we're estimating is the mean. So we know we're dealing with the part 7. Stopping distance for a new type of brake. So again, we have our quantitative variable because distance would be quantitative. For new types of brakes when used in a car that is traveling at 60 miles per hour. Yada, yada, yada. These new brakes will be installed on cars of the same model and the stopping distance will be observed. Okay. The cost of each observation is $100. This is weird. We've never seen something like this before, but we can continue. A budget of $12,000 is available to conduct the study, and the goal is to carry it out in the most economical way possible. Preliminary studies indicate that sigma is equal to 12 feet for stopping distances. This is the first time that we've been given a population standard deviation instead of an S. This is actually telling us right now that we are legitimately able to use, because we're talking about means, and whoa, we have sigma, the thing I crossed out and said we would never know. We're legitimately allowed to use this entire row, right? I do believe it said preliminary indicate. Yeah, so studies indicate. So they're basically telling us that we don't really know sigma, but let's pretend this is sigma. Because if we're doing this from studies, there's no way, this is not the real value, but whatever. So our last question here, so this basically tells us we can use the Z stuff. Are sufficient funds available to estimate the mean stopping distance to within 2 feet, so we want to be plus or minus 2 feet, which means we got our margin of error, of the true mean stopping distance with 95% confidence. So we got our confidence level as well. Explain. All right, so this question asks us to do a little more critical thinking than just say find the sample size. Oops. They're asking us, do we have the funds available to do this? Now, we might immediately go to the confidence interval formula, because the confidence interval formula is what we're talking about, right? Estimating a mean. But we don't have an N. So hopefully that kind of stops us in our tracks and realizes, oh, we need to figure out how many things we need to study. And if we figure out how many, it's $100 per observation. So I can see if we are above that limit or below that limit. So this is basically a very odd way to word a sample size question, right? So let's go ahead. We know N is Z star, and I'm grabbing this from that formula sheet. I'm just too lazy to toggle back. Times S divided by our margin of error, this whole thing squared. And we have a Z star. We're doing 95% confidence. This gives us a Z of 1.96, right? So 1.96. An S, oh, is not, we don't need S. We're actually doing this with a sigma, sorry. This is one, I didn't write that down. This I should have gone to the freaking formula sheet. Times 12 all over that within 2 that we want it to be. Square all that. So what's our math? So by the way, this is an old AP Stats free response question, which, as you guys know, I love to use on my exams because they're super well thought out and really thinky, right? This requires that we do some critical thinking in addition to some statistical thinking. All right, so we get 138.29, which means that we are going to want 139 observations. But that wasn't the question, right? The question said, are sufficient funds available? So if these cost $100 each, then we're looking at needing 1,300 or 13,900 to be able to do this, which is more than the 12,000 available. So no, and I'm lazy, I'm not writing a good sentence, but your explanation would have to be something like, no, this is going to cost us almost 14 grand when we only have 12 grand available. You could have also done this a different way. You could have used this right here to figure out, okay, that means I can pay for 120, and then you could have used that to calculate your margin of error, right? So margin of error is equal to Z star times sigma divided by the square root of n. So you could have done all your math there and seen how this compared to that too, and you would have found your margin of error is larger than 2. But that's also a completely legitimate way to have solved this question.